Hi there, buddies. This is what people say here in Vancouver, in Canada, where I'm spending a week. Today is my last day. I was attending a conference on reproducibility, and just approaching the window so you can have a look at the University of British Columbia. Anyway, in this video, what I'm going to show you is how to change the firmware of your FS-A1. Actually, yes, we already did this in another video, but what I'm going to show you is one step forward, which is instead of just removing the firmware, we are going to put something in. We are going to change the firmware, or the empty space that we have, and we are going to put a game. So let's go for it. So this is the game that we are going to put inside our MSX. It's Bugaboo the Flea, or La Pulga in Spanish. So it's a game that was developed by Paco Suárez and Paco Portalo, one of the first Spanish games. And on the MSX it's a ROM of 16 kilobytes, so it's gonna fit very well inside our new ROM. So first step, the first thing I did was to decompile the game. Here we are just doing an automatic decompilation. So here what you can see is the source code without any comments. So this is what we obtained if we called, as you can see here, directly the disassembler. So I am using this Z80 disassam that you can find as a regular program in your Debian or Linux distribution easily. So this is the command line that I used. I modified this slightly. So I started with the disassembled code and I added a few things that I needed or I wanted to improve. What I wanted to do here is first to use the empty space that I have after removing the firmware to put this ROM in here, and to be able to start the game using a call Pulga, or call whatever as you want to call your favorite game. To do this, I need some variables, like for example this proc name, which is the area that the system uses to store the name that you are calling. Then mainly we have the disassembled code, but let's have a look to see what we have. This is the header of a normal MSX ROM. If you want to see more details, you have a good entry here at the MRC wiki. But it's very simple. So you have the typical header with the AB start. You have the code that you need to call to initialize your cartridge, and here it's a statement. So this is the code that the system is going to call in order to check that the name that it's being called corresponds to your name. So we are going to see this in detail. Then you have the typical device text and reserved that we set to 0. And then you have all the original code. This we are not going to change. If we go to the end, we have our new initialization that, as I said before, we are not going to do anything special, so we just read, we don't do anything. And what is more interesting is this part, is the handler for the call command. So if you want to learn more about the call command, go there to the MRC wiki and have a look at the call. But the code is as follows. We get the area where the system is putting the name that we are calling, and we are going to compare it with a static name, a fixed name, that in my case it's Pulga. So what I want is that when I write call Pulga, the game is executed. Then what this function is doing, it takes these two pointers and it calls a function that I call without much creativity. I just call it compare strings. If the strings match, so it means that I am executing a call pulga, then I will jump to start game. Otherwise, I will set the carry to notify it was an error, and I will just exit with this red. In the case of an error, it will issue a syntax error. Then this is the function to compare to strings. I don't know, probably there are versions for sure which are way more optimized than this. Anyway, this is not a critical code. We don't need that it goes at the maximum speed, and I think it's quite understandable. So we get the pointers of the two strings, and we compare character by character until it's different or it's the end of the string. So you scan all your characters. Here you increment the pointers until they are different or not. Then I defined this function. What it does, this function, is to turn your palette in your MSX2, in our case the FS-A1, to a palette which is very similar to the palette of an MSX01. Why we are doing this? Because by default the two palettes are going to be quite different, and think that the Boogaboo game was thought for the palette of an MSX1, and we are going to execute it in an MSX2. In fact, it's impossible to have exactly the same palette, but we can make an approximation. So I don't want to explain all this code, but basically is setting the palette. Here we have the palette to mimic the palette of an MSX1, and this is the code that we are going to execute when the call pulga is found. And it goes like this. First step, we are going to set the palette to MSX colors, and this is the code that was originally in the game. So it disables the interrupts, and it does an LD to copy from the cartridge to the RAM, and it jumps to this execution to start the game. Then here I have just put a red. This is totally useless. We are not going to reach here, never, but I like it. And finally some padding to have the 16 kilobyte of ROM exactly. Okay, so next step, we need to generate full ROM for the computer, which includes our pulga. To do this, what I have done the following. Basically, I have created a script that I called build.sh, which contains the following. Let's have a look. Build, what is it here? A little bit bigger. So it's a bash script, just a few lines, so we can go one by one. First line, this set -e, what it does is to stop the execution if it encounters any error. So I would recommend that all your bash scripts include this. Next step, it takes our source code, this one that I was showing you before, which includes the original code and our additions, like the change of palette and the call code and so on, and it compiles this. It will be compiled in a file which is called by default a.bin. For me it's enough this name, otherwise we could have changed it. Here you can put -o, new name, you want .rom, but I don't need this. So what we do, we are going to create our new ROM in a file which is called newrom.rom, and we need the components in this order. First, we need to copy the basic and BIOS, those two first, so we copy it to the new ROM. Then we need the sub-ROM, this file, so I add it to the new ROM, and the last part is the firmware, but in our case we are going to put our Pulga there, so I add it to the new ROM. It will do like this. Yes, we have our new ROM, and this is not enough if we want to test what we have done with OpenMSX. Why is that? Because OpenMSX doesn't identify the ROMs by their name, but instead by their hash. So a hash is a kind of checksum. So I created a script that computes this hash, and it changes it in the XML configuration file for a new computer that I have defined, which is the FS-A1 with the Pulga call. It just does a substitution, and finally I run this machine, this modified machine. So what we can have a look is to, for example, to this script. It's a Python script, the substitute hash. Let me put it a little bit bigger. And okay, it's not complicated. What it does is it opens the new ROM and computes the SHA-1 checksum. Here we have it as a text object, and it goes to this file that I call it a template. So this template is the XML file defining the FS-A1 computer in OpenMSX. It is the same, I didn't change anything. The only thing that is different is here, that instead of having the actual SHA-SUM, I am writing template, and I'm going to change this string by the actual SHA-SUM. So this is what it does. It finds the word template, substitutes by the hash that I have here in the h variable, and it saves the new configuration. This is my new computer, the FS-A1 Pulga call. After that, normally we would have our new computer with is using this ROM, so I can just emulate the thing. So this is the command, so OpenMSX, and the machine is my new machine with the Pulga firmware. So let's execute the script. So it's called build.sh. As you can see, I'm recording with my phone now, and it's because when OpenMSX starts, it takes the audio recording device. Let's take our build.sh, let's run it. It completed without any error whatsoever. This that you can see here, which says unable to open SDL audio, is the problem that I was telling you before. It captures the device and it no longer allows me to capture. So the first thing that we need to check, if I call anything which is not Pulga, it should complain with a syntax error. Yes, it's the case, so this is working correctly. And if I call Pulga, and I can write it lowercase or uppercase, okay, this is a mistake with a P, like this, it should start the game. So let's see. Yes, it works. So with this, we have checked that our firmware in the emulator works perfectly. So next step, let's save it into an EEPROM.